All right, good morning, everyone. My name is Aaron Mahalik, and today I'm going to talk about our holistic approach to machine learning for electronic warfare at Parsons. This presentation will give you insights into how we've integrated AI and ML across our diverse company to create innovative solutions in multiple domains. All right, before I dive into my approach, let's consider the opposite scenario. What are the costs of fragmented approaches to machine learning? When we look at the entire life cycle of an ML project, from research and development to model creation, integration, and deployment, a fragmented approach is going to lead to multiple different inefficiencies. These include duplication of effort across multiple teams and programs, unnecessary costs in acquiring and updating hardware, and then lack of a comprehensive and continuous integration framework is going to lead to inconsistent products. These issues not only waste resources, but also slow down innovation and reduce our ability to respond to quickly emerging challenges. So to give you some context about our approach, let me provide you some facts about Parsons. We're a fairly large, very diverse company serving a variety of different markets. And these include traditional defense and intelligence markets such as cybersecurity, space, missile defense, but also engineering and infrastructure markets like environmental remediation, biosurveillance, and rail and transit. Despite this diversity, there's a common thread running through all of our solutions and operations. Data, technology, AI-enabled solutions underpin a lot of the products and services that we offer our customers. This shared foundation allows us to leverage insights and innovations across these different sectors. So concretely, let me provide you some sample projects from across the company.
Please visit the Reynolds Stream Pavilion.
This slide illustrates the breadth of AI and machine learning applications across our company. This includes defense and intelligence products like our solutions to optimize mission planning, logistics, conduct behavior and pattern of life analysis in order to predict adversarial courses of action. In engineering systems, we're using computer vision for counter-UAS detection and tracking. And we're using these same approaches and technologies and infrastructure as well. We're monitoring traffic, we're looking at roadway assets, and we're tracking the progress of construction sites. These diverse applications of AI demonstrate how we've integrated our approaches across the entire business, allowing us to meet a wide range of challenges. Early on, we recognized the transformative potential of AI across all of our operations, and we made a strategic decision to elevate it to the corporate level. We created an AI center of excellence that drives our AI strategy across the company. This centralized approach allows us to maintain a consistent AI strategy across our diverse domains. It enables our domain experts to focus on their specific areas while leveraging shared AI resources, and then it provides a company-wide support for AI policy, tools, and expertise. By doing this, we ensure that our domain experts can operationalize AI effectively, putting their specialized knowledge at the forefront while benefiting from a robust company-wide AI support structure. When I think about AI programs across Parsons, I see three key areas. There's the core research and development, there's the model lifecycle management, and then there's testing, evaluating, and demonstrating our solutions. While individual programs may focus more heavily on one area, all three aspects are present in every program. The key advantage of our centralized AI strategy is that approaches, lessons learned, and even personnel can be shared out throughout the company. This cross-pollination of ideas and expertise enhances our ability to innovate and solve complex problems. So let me dive deeper into each one of these areas. So in terms of research, our Parsons researchers are continuously evaluating the latest developments and trends in models and solution architectures. We're always looking to understand how these advancements can be applied to our customers' domain-specific problems. So for example, a concrete example, transformers are currently dominant in many AI applications, but we continuously experiment with other novel architectures. For instance, neural ODEs, which emerged in recent years, are interesting because they can model continuous, sparse, and aperiodic time series data. This data set aligns perfectly with challenges we're having in maritime track prediction. We're able to take this new architecture, extend it to incorporate domain-specific nuances like environmental constraints and coordination between entities. This type of R&D effort allows us to bridge the cutting AI research in academia and in the commercial realm with real-world domain-specific challenges our customers face. Along with constant research in model architectures, we're constantly evaluating changes in hardware. Over the last 5 years, we've seen an explosion in specialized AI devices, including traditional GPUs like NVIDIA's Jetson series, and application-specific devices like Intel's graph processing units and IBM's neural compute units. Recognizing this trend early on, we developed Project Edge, which focuses on efficiently evaluating the underlying hardware for our customers' use cases, abstracting away these hardware details for our analytics, and developing repeatable, hardware-agnostic, DevOps-like pipelines for deploying our analytics on this new hardware. This type of research ensures that our solutions remain flexible and adaptable as hardware technology continues to change. Finally, in terms of research and development, one of the last pillars of research is data, the foundation of all of our analytics. And this has special relevance in the EW domain because oftentimes we have to rely on synthetic or heavily augmented data sets. Oftentimes to address this, we repurpose independently built tools and environments to create and collect our data. A prime example of this is our T-Rex or Threat Representative Environment System. This tool allows us to generate synthetic data in the EW domain, including both signals from our comprehensive signals library or behavioral traits from our ability to emulate threat emitters. And T-Rex can serve a dual purpose. It can both generate data for training our models, or it can serve as a testing and evaluation environment for existing analytics. Again, this capability is crucial in the EW domain where real-world data is sparse and scarce. It allows us to develop and refine our algorithms in a controlled yet realistic environment. So, in order to manage all these processes, from model development to hardware evaluation and data generation, we need a robust platform for collaboration, and that's where the Parsons development environment comes in. This is a singular, centrally managed platform that hosts multiple different environments aligned to different security requirements and project needs. At the top, we have the most secure environment, the secure product environment, which is for projects that require an unclassified air-gapped environment. Next down, we have the protected development environment, which is capable of handling CUI information, but is also internet connected. And below, we have the open product environment, which is for less sensitive projects. These environments host a standard set of DevOps tools like Bitbucket, GitLab, Jenkins, and Atlassian products. And they also offer access to cloud services like Azure or AWS for additional compute and storage needs. And importantly, we can bring in customers and subcontractors into these environments. We can issue them accounts, and this enables collaboration while maintaining appropriate security measures. So beyond our software infrastructure, Parsons has a diverse set of facilities that are suitable for testing, evaluation, demonstrating, and collaborating on our solutions. We have a strong commercial presence in partnerships in some of these facilities with access to commercial products and services. And these facilities cover a breadth of use cases from C5ISR and space awareness, to machine shops and prototyping specialty engineering facilities, to digital engineering and model-based system engineering labs. These facilities allow us to bridge a gap between theoretical development and practical application, and allow us to evaluate our solutions to ensure that they are robust and ready for deployment. A notable highlight is our Paladin lab at Aberdeen Proving Ground. This state-of-the-art facility serves as a hub for innovation in multiple defense domains, including electronic warfare. It provides a unique environment where we can prototype and test new concepts, we can collaborate with government and industry partners, and we can demonstrate our solutions in a secure and realistic setting. Paladin has almost 10,000 square feet of open space for collaboration, has on-site servers with cloud resources, with massive amounts of operational data to test our products. We have breakout rooms, demo rooms, and secure spaces for all sizes and sorts of collaboration. So as I close, I'd like to put everything I've discussed into practice by walking through a specific example of an analytic we created in the electronic warfare domain. In this example, we're detecting background noise in audio samples. This is a well-established problem, well-studied problem with commercial solutions. If you have an iPhone, you can enable it to listen to background noise to help it understand what your environment is. But for our domain, there are significant challenges compared to these commercial products. We have to deal with degraded and compressed audio. And if we examine the spectrogram of this audio that you can see on the upper right is the raw audio. On the bottom left, on the bottom right is the audio that we receive. You can see that the degradation is clearly visible, and off-the-shelf models will perform poorly while analyzing this data. This spectrogram, this example, shows how the signal is distorted and fragmented, making it difficult for standard algorithms to extract meaningful information. Also, we can qualitatively assess and visualize how a typical off-the-shelf model will view this data. As the audio gets messier, so starting on the left, you can see what the clean audio looks like. Each dot is a sample. Every color is a type of background audio. As the audio gets messier, so in the center, as we degrade it, and as we overlay other sorts of audio like voices on top of it on the right, you can see that the model will fail to accurately interpret the data. It'll miss key features and misclassify others. To address this challenge, we applied our holistic approach. In terms of R&D, we developed tools to create degraded audio samples from clean sources, and we experimented with methods to curate the right mix of audio samples to train our models. We developed novel architectures and configurations, including coupling both a classification and confidence model in order to make our solution more sample efficient. And we're currently experimenting with multimodal architectures for zero-shot learning. The confidence model and zero-shot learning approaches are significant ML innovations that can be used to process and identify unknown signals. The confidence model allows us to quantitatively measure how unknown a signal is, and the zero-shot methods, coupled with natural language models, allow us to generate descriptions of these novel signals. Additionally, in terms of model management and realistic evaluation, we're able to do our training and testing on Parsons hardware, allowing us to pull in other resources across the company. And we built a unified deployment container for various platforms on our build environments. In terms of evaluation, we were able to bring our customers' hardware into lab to integrate our solution and ensure a seamless integration and performance. All right, to wrap things up, let me recap some of my key points. Parsons develops solutions across a diverse set of domains, and we've made AI a central cross-cutting technology throughout our organization. Our AI Center of Excellence drives innovation across all of these portfolios, ensuring that AI is deeply integrated and applied consistently across our company. We've developed comprehensive approaches to AI solutions that span from targeted research to development to deployment and testing. And then finally, our labs and integration facilities like the Paladin Lab serve as both collaboration spaces and proving grounds. Here we can rapidly test, refine, and deploy our AI-driven solutions, ensuring that they're mission-ready and operationally effective. This holistic approach allows us not only to address today's EW challenges, but also to anticipate and prepare for future needs. By combining our diverse expertise, centralized AI strategy and cutting-edge facilities, we're able to deliver innovative and reliable solutions across an evolving landscape. I thank you for your attention this morning. I'm happy to take any questions you might have.